All right, thank you. Thank you guys for attending this talk. I am Gene Pang, and I'll be talking about Spark pipelines in the cloud with Alluxio. So before we get started, I will briefly introduce myself. My name is Gene Pang, and I'm a software engineer at Alluxio, and I'm also a PMC member of the Alluxio open source project. Before I joined Alluxio, I received my PhD from the AMP lab at UC Berkeley, and before Berkeley, I was working at Google on distributed databases and distributed systems. So that's sort of a brief introduction to myself. Here you can also see my Twitter handle and GitHub handle. So this is a brief outline of what I'll be talking about today. I'll first go over an introduction and overview of Alluxio, and then I'll go into data pipelines, how they work, and how Alluxio can provide benefits to pipelines in the cloud. And then I'll briefly go over a simple experiment that we've conducted with Alluxio and pipelines in the cloud. So before getting into Alluxio, here's a brief history of Alluxio. It originally started at UC Berkeley in the AMP lab in 2012. And actually back then it had a different name. It was called Tachyon back then. And early last year, 2016, it was rebranded to Alluxio. So it's the same exact project, same code and everything, except the name was rebranded from Tachyon to Alluxio. And then in 2013, it was open sourced. And the latest version of Alluxio is 1.6.0, which was, I think, released a few weeks ago or like a month ago. So you might be wondering, what is Alluxio? Well, at its core, Alluxio wants to unify data at memory speed. And so there are three major components that Alluxio wants to achieve. One is namespace unification. So Alluxio provides a unified and global namespace for your existing data that you may have. So if you have different storage systems in various places, Alluxio can provide a single unified namespace for you and for applications. Alluxio can also enable architecture flexibility. So Alluxio sits in between existing storage and existing applications. So since it's in between those two layers, it's actually really enables the flexibility to use different storage systems and different applications. And so this Alluxio, by being at that layer, can really enable that type of flexibility for deployment and environments. And also, Alluxio can provide increased I/O performance. And so Alluxio has something called tiered storage, which it can manage data at different storage mediums, such as hard drives, SSDs, and memory. And so since Alluxio can store data in memory, it can really increase the I/O performance for applications. So here's an image of what the ecosystem and architecture will look like with Alluxio. So you have storage systems at the bottom of the diagram with like HDFS, cloud storage like S3 and Microsoft Azure storage and other types of storage appliances. And so there's lots of different storage systems underneath Alluxio. And then there's a lot of sort of frameworks and applications on top of Alluxio. And obviously Spark is a big one, but there's also other ones are supported, such as MapReduce and Flink and so on. So Alluxio sits in between the storage layer and the computation layer, and by doing this, it can really enable a lot of new things. Such and this will essentially separate compute and storage, and so it gives you that flexibility. Applications really only need to talk to the Luxio API and be able to access all the other different types of storage that you may have. And applications don't need to change. They just need to reference different paths in the namespace and be able to access different storage systems and data. And also, Alluxio at this layer can help keep the important data in memory and thus improve performance of applications. So with this architecture with Alluxio in the picture, it can really enable a lot of different things in a lot of different spaces. And so Alluxio can be used, is used in many different scenarios like big data, machine learning, IoT, deep learning, things like that. Also, it can be deployed in many different areas. It can be deployed obviously on-premise, but also it can be deployed in the cloud or across cloud. So you can really mix and match all these different types of environments and have Alluxio provide benefits for you there. Also, Alluxio is an open source project, so it is also one of the fastest growing open source projects. And so here is a graph of the number of contributors on GitHub sort of across the time that it was open sourced. And so Alluxio has been open source for maybe about 4 years. And so this is sort of the first four years of data. And as the Alluxio is the top blue line, and this graph is actually a little bit stale, but if you go on GitHub today, there's over 600 contributors to Alluxio. So it's just been really great to be a part of this type of community. It's fast growing, and it's also great to see the different types of use cases that people are using with Alluxio. So next, I'll talk about data pipelines in the cloud and how Alluxio can provide benefits for data pipelines. So for the purposes of this talk, this is the type of data pipeline I'll be talking about. Essentially, there are different stages of the pipeline, and ultimately, the output of one stage is the input for the next stage. And that's the high-level idea of the pipeline that we're talking about here today. And so this diagram briefly shows that type of a simple pipeline. There are 4 stages in this pipeline, and the output of stage 1 is sort of feeds into the input of the stage 2, and so on. And so this is the simple view of the pipeline that we're using today. But it works more like this. So in order to essentially pass data along to the next stage, the stages have to write the data out to some storage system, and then the next stage will read it back, and then so on for the input. So essentially, the sharing of data happens through an external storage system. And so in this case, as you can see, there are, the different stages are writing to shared storage, and the different inputs are read from the shared storage. So if you have a pipeline in the cloud, what does that look like? How does that work? And so that's a natural question to have. So in the pipeline, you have the same exact setup. You have different stages of the pipeline, and you also have a storage system. And so typically in the cloud, the storage systems are object stores, or in the Amazon cloud, it's S3. And so in this type of scenario, these stages have to read and write to the Amazon S3. And that can actually be pretty slow. Since Amazon S3 is an object store, it will be remote to your jobs, as well as you'll have to incur some of the network costs, incur some of the metadata costs, and things like that. So as you can see in the animation, the arrows are slow because reading and writing constantly to S3 can slow down the jobs and also slow down the entire pipeline. So ultimately, what's happening in the cloud is that we're sharing data across different stages via the cloud storage system, and that can slow down the performance of the jobs and thus slow down the performance of the entire pipeline. So when you put Alluxio in the picture, the picture looks more like this. And as I mentioned before, Alluxio sits between the applications and above the storage systems. So here we have Alluxio in between the 2 layers. And in this scenario, since you can write directly to Luxio memory, all the stages can read and write directly to Luxio memory. And so the writing is faster, the reading is faster. Ultimately, the sharing of data between the different stages occur via the Luxio memory and not have to go all the way down to S3. And so this can really speed up the writing portion of the jobs, the reading portion of the jobs, and also ultimately cut down the time of the entire pipeline. So in the cloud, ultimately, sharing of data looks something like this. There are stages that sort of need to pass and share data amongst each other, and the previous job has to write the output out to the storage, and the next stage has to read that data from that storage, and this is what it would typically look like. But with Alluxio in the picture, it looks more like this. Each stage will actually write to memory, and the next stage will read from memory. Ultimately, the sharing, Alluxio will enable the in-memory sharing of data, and this can lead to faster pipeline performance because of the faster reads and writes that the jobs have to do. So you might be asking yourself, like, how does this work? Like, what is Alluxio doing here? So at the core of it, Alluxio has a feature called fast durable writes, and this is the feature that is used for this type of pipeline and writing in the cloud. The ultimate goal for fast durable writes is to improve write performance, but not have to sacrifice the fault tolerance and durability of the data. And so fast durable writes has two major components and two major steps to the feature. First, applications and clients will synchronously write to multiple replicas to Alluxio memory. And then next, the second step is that Alluxio will asynchronously write that back out to the underlying storage. And so this combination of concepts is really powerful, especially when you're putting Alluxio on top of some slower or remote storage or things like that. So it can really hide the performance penalty that you may pay by reading and writing to something like an object store. And so this is sort of like a brief summary of what the fast durable writes feature is. And so next I will go into, I'll demonstrate sort of how this works. In this example, we have a storage system on the right, and then we have Alluxio sort of in the middle, of the page, and then we have applications and clients on the left. And so Alluxio is sitting in the middle between the application and the storage. And so, the first stage of fast durable writes is that the applications will write multiple copies to Alluxio, to the Luxio memory. And so this actually is a configurable parameter, so you can write as many copies as you would like, depending on the fault tolerant profile that you want. But in this example, there are two. So after that's written to two copies, the write is considered complete. And so the application can continue and move on and continue the processing. Now, in the background, at some later time, Alluxio will actually asynchronously write that data back out to the storage system. So in the previous example, in the Amazon cloud, it'll write it back out to S3 at some later time. And so this essentially decouples the writing to the backend store, the underlying store, from the application. The application does not need to wait for the write to S3 or need to transfer the data out there. It just needs to write to multiple copies in Alluxio memory and then move on, while Alluxio will take care of writing it out to S3 for you at some later time. And so this is sort of the summary of how the fast durable write feature operates in Alluxio. And so next I'll go over a brief example of a pipeline and something we ran with Alluxio and show the benefits of Alluxio. So here's an example pipeline, a log processing pipeline that you can think of. And this is we ran it in Amazon EC2. And in this example, we have it's a 4-stage pipeline. So in this example, we have 4 stages, and we've named them generate, parquet, transform, and aggregate. And so in the generate stage, we essentially generate a bunch of CSV log data. In the parquet stage, we convert that CSV log data into some sort of parquet format. And then in the transform stage, we will take that parquet input and update some of the columns and some of the values in those columns. And then the last stage, we'll aggregate and compute a group by and aggregate on that data. And so this is sort of the example pipeline that we have. Something else to note is that we're using different frameworks here. We're using, for the first two generate and parquet stages, we're using the MapReduce framework. And for the transform and aggregate stages, we're using the Spark framework. And so this also highlights how you can share data between different frameworks and applications in memory with Alluxio. So with this pipeline, here's the environment that we used for the experiments. We ran it on Amazon EC2. We used the R4 2x large instances, which has 61 gigs of RAM and 8 CPUs. And for this example, we had one master and 3 workers for all the different systems that we've deployed. And so this is I've listed some of the software that we've used along with our version. So we're using Spark 2.2.0, we're using Hadoop 2.7.2, and we're using Alluxio 1.6.0. And so in this example, we are generating 12 gigs of logs. So in that generate phase, we're generating 12 gigs of data, and that's about 4 gigs per machine, since each worker since there are 3 workers. And we essentially ran it once with the S3. We ran the pipeline in S3, sharing the data with S3, and also sharing the data with Alluxio and fast durable writes. And so we ran the pipeline 3 times in each configuration, and we took the average completion time of each stage. And so here is a graph of that data. The red bar is the completion time for when we're sharing sharing the data with S3, and the blue bar is the completion time of each stage when we're sharing the data with Alluxio. And as you can see, the red bars are much larger than the blue bars, and that means it's slower than the blue bars. And so with Alluxio, since the applications can write directly to memory, to several replicas, and then essentially continue on, they don't have to wait to write to S3 or read from S3. And so so you can see that for some of the stages, it's over 10 times faster to read and write to Alluxio than it is to read and write to S3. And if you take the full pipeline, if we just aggregate the full pipeline time, it looks like this. The larger bar is the sharing via S3 line, and then the shorter bar is sharing with Alluxio. And as you can see, the completion time is over 9 times faster with Alluxio, and so this essentially means you can process the data much faster. You can get insights out of that data much faster, and thus produce better results in the future. And so this is just a small example of how Alluxio can be used for pipelines in the cloud, and what type of benefit is possible with Alluxio. So in conclusion, I described Alluxio and showed how Alluxio can enable in-memory data sharing between different stages and different jobs for pipelines in the cloud. And this is especially effective when we're running in the cloud with slower object stores. And also I talked about the fast durable write feature, how that is what enables a lot of these benefits, and how how fast durable writes will try to increase the write performance for writes, but not have to suffer for the fault tolerance. So thank you very much. That's the end of my talk. Are there any questions?
So I have 2 questions. So one is related to locality. So is Spark aware that a given copy or whatever of the data is co-located like in the same box as the worker using Alluxio?
Yes. So Alluxio does provide that information to Spark. So Spark will use that information and schedule tasks that need to read that data on the appropriate node that has that data. So it can read it directly from memory.
And yeah, cool. So my second question is about the asynchronous write. So can you make it synchronous? Because some of our use cases, we need to deliver the data in the end. So it really needs to be there. So like, can it, like the final write step be synchronous?
Yes, that's a great question. So fast durable write is only one configuration of a write. You can configure other types of writes, which is I think we call it cache through write. So in the cache through write, it's a synchronous write to S3. So if in the last stage you need the result like immediately in S3, then you would actually configure that write to be cache through and not fast durable write mode, and it will synchronously write to S3 for you. So yeah, that's a configurable thing that we can do with Alluxio.
But like, is there an API for that? So when I, for instance, in Spark do like write ORC and then some Alluxio namespace file, is there like an additional thing that I put there to make sure?
Yes,
like, is it that easy?
it's a configuration parameter that you can set for the Java ops. So you can set a Java option that essentially enables the write to look like a synchronous write.
But it's global, so I can't say all these jobs in my context are asynchronous, and then this final one, this final write, is synchronous.
Oh, I see. I think if you set the Spark Hadoop configuration, that'll also propagate that parameter. Yeah, I think that's possible. I'm not exactly sure, but I think that's possible that way.
Gene, thanks. I had two questions. The first is, my first question is, obviously if you're running S3, that doesn't consume any resources on your cluster. So if you could just tell me kind of what your intuition is as far as how much resources you need to provision for Alluxio, given that you have, one or two are a multi-tenant Spark cluster, and how that scales with, as you scale up the demand essentially, and how that's handled.
Yeah, that's a good question. That's also a tricky question. It really depends on the workloads. I would say, ideally, if you're looking for like the highest performance, you want to co-locate the Alluxio workers with the Spark workers so that you can directly write and read from local memory and local storage media. In terms of the resources, Alluxio primarily consumes like storage type of resources, and that would mean hard drives, SSDs, or memory. And since it needs to store data for you closer to the application, that's the primary resource that is used in Alluxio. So if you're like concerned about CPU, then Alluxio will not consume like it'll only be a trivial amount of CPU. But in terms of storage, that's the resource. That's the main resource that Alluxio uses.
So do you have to like 2x the size of the boxes you're using, or is it just a little bit more?
It really depends. Like it depends on how much data you want. Essentially in memory. Okay. If you want more of the data in memory, you'll need more memory. If you want more of the data like an SSD, then you can just get more SSDs. It really depends on sort of what, how you want to optimize your jobs.
Okay, thanks. And I said one quick second. Oh, okay. What is the current state of Alluxio interacting with the various security features of the other storage devices? So do you authenticate, or do you like have a security thing that's in
Yeah,
that
so
one layer?
Luxio, it does have security. It's primarily, it's sort of like, it sort of follows the POSIX model. So it has, it does the ACL, it does the access control through like the POSIX model for like a file system. So it maps well with like the HDFS type of security model. But in terms of the, but there is also a mapping. There's a type of mapping that you can do for like the ACL lists that S3 has. So there's like there are ways that's compatible with. What users will see in Alluxio is the POSIX model, but you can configure it to map to the S3 model as well.
Have you looked at scenarios where you've got an on-premise and a cloud-based environment, and can Alluxio cut across those and have a data pipeline that deals with data on both sides of the fence?
Yes, we have seen some deployments where people have data in both places, or people have compute on both on-premise and cloud, and they try to use Alluxio to help with that. And so, the nice thing about that is application writers don't need to worry or be concerned with where the data was coming from, and Alluxio sort of hides that complexity from the application. So there are some examples of that we've seen.
Okay, if there are no more questions, thank you, Gene, for your talk, and the next talk begins at 20 past.
Thank you.